Create sketch. This is our top plane. Okay. Line first. This shape which I made is also a delta wing. Okay. Another shape like this. Would also come in delta wing. And a simple triangular shape like this will also come in delta wing. Whether we have it like this only. And note this section. This will also a delta wing. Today we make a delta wing. First we have to make a profile where which type of delta wing we are going to design today. Let's make a compound delta wing like in Tejas. Okay, but these are free to move. They are moving here and there. We have to fix these points to each other. This is the command which we use for fix joining two points. First select this, then select this, it will be joined. Select this at this would be the center, this and this. Okay, I will, this is horizontal, making it horizontal. Okay, now here it is a vertical line to make it vertical. Done. Now joining this with this and this point with this point. Now I have a rough geometry where which would be the top plane of a delta wing. Now I will give some dimensions. A vertical dimension from this point to this point. Let it be 100 mm. Okay. When it goes out of screen, click here and four options. Zoom to fit. It will be fitted in your screen. And this would be code and horizontal distance. Let it be 60 mm. Now this part is left. Let it be placed here. But this is free to move, so I will have to fix it with some constraints like giving angle at here 69 degree. Let it be 69. Will not change. Oh, sorry. 16. Okay. Then angle between these lines 145. Fine. Now it's all in green color. Green color indicates that it's fully defined and no more dimensions are required to make it stable or define. This would be shape of our delta wing today. Okay, now update this figure and came out. Now I will see a isometric view and then zoom to fit. Now another sketch on ZY plane. Here it is, which would be perpendicular to this. Okay, from this point to this is our profile. You can see like this. Okay, now I am making here an airfoil, which will be required for an delta wing. At this point, I am making a circle with some radius. Let it be 10 mm. Now fixing this point from here, I would make it 90 as 10 mm is radius, and which and the full tip should match here. Okay, now it's whole 100, 90 plus 10, 100, and another circle which I will make here with much lesser radius. Let it be 5 mm only. Okay, and this distance would be fine. Now I will take it here at some distance so that no mesh is created. Dimension should be clear. Now here I will take an 3-point arc starting from this point to this point, passing from here. Okay, but this is free to move as it is not green, so it means it is free to move. Now I will fix these points. First, this point on this curve. This sign is used to fix a point on a curve, and this on this. Now it will not move. It will move whole, not separately. Okay. To make it fix, vertical distance of this point to origin would be 0, and this point from origin would also be 0. Now it's fixed. Here I will give a tangent this arc to this arc and this arc to this arc. Now it is all tangents. It is clear. Then again, and 3-point arc from this point to this point. Excuse me. From this point to, I guess, this point, like this. Okay, I will now fix this point over this arc. Done. Then what I have to do, give a tangent between these two. Done. Now I will make another arc from this point to this point, like this. Okay, but it is free to move. Now I have to do two things, fixing these points together select this and then select this. Now giving tangent between these two arcs and then fixing point on this arc, again tangent of this and this. Okay, now it is done. I will remove these extra parts by this trim command. This one and this one. Now I have a airfoil shape. It is, I should take it 3 mm. Okay, now it would be bit fine. Yeah, this airfoil shape is fine for now. Update, but it is not green. We have 5 degrees of freedom. Here we can select, choose. Okay, but make it green, I am giving random radius to these arcs. Okay, as I can see this still to let me give vertical distance between these 2 points. This point and okay, this point and this point, vertical distance, let it be this, and a horizontal distance be this. Now it is fixed, and whole green means it is completely defined and no more dimensions are required here. These three diameters or radius and these distances are just to make it green, nothing else. As such, they are not required, or it would be required when there is a specific airfoil given to you, like Naka airfoil with with some coordinates. And in that case, we have to make only that airfoil with the with coordinates which are given in that airfoil. Now it is made here. Let me see from top. Here is our airfoil completed. Now another airfoil with approximately same shape I will make on this plane. Okay. For that I need to create a plane at this part, and for that I need distance from this line to this point. For that I'm going to this sketch, marking my distance, horizontal distance from this point to this point. It is coming 29.16. Okay, 29.16. Close. Now take, this is a datum plane. To create a datum plane along, from here I will again go to isometric view so that I can see that datum plane is coming at the right place or not. At ZY plane 8 and then datum plane. Okay, it at a distance offset in x-axis it would be 29.6. Okay, no, edit, not in z, z 0. Yeah, I think it would be by 29.6. No, and then let it be in z 29.6. Okay, you can see it would be on at here we got a datum plane, a ref, or you can say a reference plane. Now I will select this plane and sketch over this. Here we can see a previous airfoil which is on the back at the origin. Now here this was the point, like that. Similar way I will make an circle here like this. Okay. Now giving radius to this circle, it is giving 6.66. Let it be only 6. And the one thing we need to see that it's tip. First I will make vertical dimensions for this circle. That would be 0. Okay. Let it be at side. Without while making a horizontal dimensions, I would like to place it here. And now making a horizontal dimension with this. Let it be what it's come up with. Okay, done. Now again I will make another circle at this point. Okay. First I will give vertical and horizontal vertical dimension to this, that is 0. Okay, fixed on this axis. Now I will give radius to this. I think I will give it at 1 mm. Okay, now horizontal direction mm also. Sure. Okay. Sketch 2. Here you can see this attaching with attaching here. Okay, this is fine. Now similar task here, 3-point arc will take from this circle to this circle somewhere like this. Okay, here we come up with one arc. Now what next? Sending these points on arcs. Let me zoom in. Then making them tangents. This and this. This and this. Okay, we have one arc completed. Now from lower end here to here like this, and from here to here like this. As such, this is not an airfoil for Tejas. Tejas has different airfoil, which we will do in next class probably. Taking this point and this arc and this point on this arc. Done. Now joining these two arcs end to end, making this point and I need to zoom these 2 points. Now making them tangent to each other. This arc and this arc. This is tangent. Now similar here, these two tangents. Similarly here, these two tangents. With this. Okay. Now we need to remove that extra part from of the circle from here and also from here. Another airfoil of this section is completed. Okay, we again these are not fully defined, so what we need to do, again this is not tangent. Now it's fine. Now I will give radius to this. Okay. Okay, now make I'm trying to make it constant or stable with the horizontal distance, whatever it will come. Four degrees of freedom are there. Let me check which are. Only those are the. Let me give vertical distance of these points. Sorry, horizontal distance, so that I could make them fix. You can fix them by any means, by giving radius or by giving horizontal and vertical distance that will fix that those points on that location. Now we're giving it a vertical distance from center. Okay, but we don't need to make it that much constant. But now we got our profile. Let's close it. look at isometric view. Here these are profiles. It will come up here like when we give it such like this. It will be coming like this. Now another plane I will take a little bit here and make it smaller airfoil here, and it will come up like this. For now I'm cancelling it. I don't require this one. Another on YZ plane, datum plane, distance took that 60, so it will be 59. We can see it from front so that we could know where it is going, and that will be 58 mm. Okay, now on this datum plane I will sketch another airfoil which would be like this only this portion. For that I would need to zoom it and check whether this airfoil don't don't goes out from this part, only from here to this point. So for that, first I will need a circle, a smaller one, I must say. First, making it vertically straight, coinciding with the axis, letting it 0, then making a radius of 0.6. Let it be 1 mm. No, zero point 0.6 would be enough. And 5 mm would be enough. Okay, now this horizontal distance giving for fine. I don't have any problem with this dimension. Now here a smaller circle will come up. Let's its dimension be 0.29. Let it be. We are not going with hard and fast rule. 0.29. It would be here only 0.29 mm away from the origin. 0.29. Fine. Okay. Now this vertical distance to make it greener. Fine. I am done with this. Here what we need, then 3-point arc tangent to these two, and much flatter than the previous one because it's going towards the end, and ends are always flatter and not much bulge. Airfoils are to be selected according to its place from a little bit curve only, giving tangent to these two. First fixing this point on this curve. Okay, then making tangent to. Okay, then another 3 point arc from this to this and like this. Now let's join these 2 points. Can't join these 2 points, don't know why. Okay, that were joined, but I could not see that because of the tangent. This two tangent, then this point over this circle. Done. Like this. I am done with this profile. Now trim these extra circle, part of circle, cut out and cut out. Let me give radius of this cell file, but yes, again and again it is going back. I don't know why it is not. Now from here, this trim section, trim the exact circle. Okay, fine. Sections and constraints. I don't know why this error is coming. Let me check first. Which okay, now it's fine. No error is showing here. Close. Here we have three airfoils section. Isometric view. I will hide these datum planes. Okay, from sketch 3, loft, add section, this section, add section, this section. Okay, it is coming in curved shape, but we need a straight shape. For that, what we need to go in part design. Here, we were working in a part, that's why. Now it's part design. I need to hide this one. What we need, this section, add this section, another adding this section. Okay, here we come up with an rectangle rectangular foil, which is a delta plane. You can see. I think we have made that section outside the required plane. That's why I guess from top view we can see it here as a rectangular shape, and cut sections are our okay, but this is not a good shape which we require. I just made it with assumptions. I guess the second plane we took from there has a full section, maybe outside, or the section at first plane maybe inside. That's why it's showing this curve. Otherwise, it always come up with a straight lines like we made in sketch 1, like this. This always come here like in straight angle, and here to here it's straight line, like this is straight lines. Maybe curve, this curve is due to not precise dimensions, and as dimensions would be precise only when we have some data that requirements, it requires this angle of attack and this foil. During that, when we have whole data and requirements, with that we can make with precision, and that precision will come led to the perfect shape of an airfoil. Now this come up with like this. There is another airfoil for which is mostly used for delta wings or high speed aircraft, supersonic aircrafts. That would be covered in next session tomorrow. That airfoil will be flattened airfoil and have much impact during high speed aircraft takeoff, high speed flights. Here we come up with this as we make the airfoils, but kind of airfoils we have made. So thank you for today. Thank you for today. That's all for today. Meet in next class tomorrow. Thank you.
Thank you, sir. We can end the session.
Thank you, sir.